All right, let's dive right into this explainer and look at a classic mistake that will literally drop you a full grade boundary in Cambridge biology. Picture this. You open your paper, you see a question on the effect of enzyme concentration on reaction rate, and you smile. You're thinking, hey, I know this. You write down your answer, feeling super confident, but then results day rolls around and you've completely missed the mark. Why? Well, because A-level biology isn't just about what you know. It is entirely about exactly how you prove you know it.
Now, what's really wild about this statement is that the biology isn't actually wrong. In a total vacuum, sure, it's true. But using that kind of generic phrasing completely ignores the specific context of your exam question, and boom, you immediately lose the mark. Examiners literally see this exact sentence thousands of times every single year, and every single time it gets a big fat 0. Honestly, it's a middle school answer sitting right there on an advanced level paper.
So to avoid that heartbreaking error, we really need to wrap our heads around the fact that Section 3.2 of your syllabus is definitely not just about memorizing facts. We're talking about the analytical study of how varying enzyme amounts actually impact reaction speed. Cambridge absolutely requires you to use context-specific evidence and incredibly precise terminology. The whole shebang is about analytical depth and connected conceptual understanding. If you're just out here regurgitating a flashcard, you are falling straight into their trap. Which brings us to a huge question. Why does perfectly good, hard-working revision fail to build the transferable reasoning you need for those weird, unfamiliar exam contexts? You know, you can spend hours highlighting your textbook until it's glowing neon, but if you don't know how to distinguish between merely describing a trend and actually explaining the deep biological mechanism behind it, you're going to hit a brick wall. This exam is custom-built to test your reasoning, not just your memory.
And that leads us straight to the core principles. Look, examiners want to see you apply established biological principles using systematic analysis and hard, evidence-based reasoning. They're looking for connected conceptual understanding. They want to see if you can take your reasoning and transfer it to some completely bizarre, unfamiliar context, like, I don't know, an enzyme from some deep-sea bacterium you've literally never heard of. You absolutely must prioritize analytical depth over superficial breadth. Trust me, it is way better to thoroughly explain one key interaction than to just list 5 vague facts.
Now, in just a second, I'm going to reveal the exact examiner clue that will completely change how you write your answers. It's this one little thing hiding in plain sight on your exam paper. But before we get to that, you really need the methodological framework that's going to make that clue totally obvious to you when you see it.
All right, let's jump into Section 1, the Method Mark Strategy, Securing Points Through Process.
Did you know that Cambridge actually awards marks just for showing you know the correct practical process, even if your final calculation is a total mess? This brilliantly highlights the procedural framework you absolutely need to lock into your brain to grab those safety net points. First up, you've got to select the appropriate apparatus. Second, follow those sequential instructions meticulously. Third, make really precise, accurate observations. And fourth, record all that data in suitable, well-headed tables. This isn't just mindless busywork, guys. This is the structural foundation you need to draw solid, evidence-based conclusions and reliably spot anomalies in your practicals.
And because data interpretation is basically the lifeblood of this topic, you have to know exactly which statistical tests to whip out. If you're comparing two means, you're going to reach for the t-test. Dealing with categorical data, that's chi-squared. And if you need to find a relationship between variables, like, say, enzyme concentration and the rate of product formation, you're going straight for correlation tests. Picking the wrong test is a massive red flag to the examiner that you just don't get the data.
Moving right along to Section 2, Critical Analysis Skills. Deconstruct, solve, and evaluate.
Let's raise the stakes a bit and see exactly how top-scoring candidates evaluate their findings. To genuinely evaluate the quality of your evidence, you've got to actively question the assumptions made during the experiment. Like, was that temperature actually kept constant, or did you just cross your fingers and assume the water bath was perfectly stable? You need to consider different perspectives, hunt down strict limitations, and ultimately justify every single decision with hard evidence. It's on you to figure out the exact impact those limitations have on the validity of your conclusions.
Notice how the top-tier approach structurally guarantees you're going to hit the mark scheme. Your basic, run-of-the-mill candidate will just spot a similarity or a difference, and usually they won't even quote any data to back it up. But a top-tier candidate, they identify similarities and differences. They use awesome comparative connectives like whereas or conversely, and they support every single claim with actual data pulled straight from the graphs. That is exactly how you draw conclusions about relative importance and lock in maximum marks. All right, time for a super quick challenge. I want you to mentally lock in your answer as we look at what failing to apply these critical analysis skills actually looks like on a real exam paper. Put your examiner hat on for this next student response.
Okay, did you spot the difference? The flawed answer just says, higher enzyme concentration means more enzyme substrate complexes are formed. Sure, biologically that's true, but it is way too vague. Now check out the improved answer. In this specific investigation, higher enzyme concentration increases successful collisions per second, assuming substrate concentration is not limiting. See that? This improved answer totally secures the mark by integrating context, using highly specific terminology like successful collisions per second, and most importantly, calling out the limiting assumptions of the experiment.
And this brings us right back to that open loop from earlier. The ultimate examiner clue, the one thing that totally transforms your answer, is the context provided in the question's preamble. That little introductory paragraph before the graph, that is not just flavor text. It contains the exact, specific scenario you have to link your answer to. If they take the time to mention a specific pH buffer or a totally unique temperature, your answer absolutely must reflect that environment. Let's do a really quick recap of these warnings straight from the principal examiner reports, so you can build a solid mental checklist. Number 1. Answers are way too vague. You have to demand specific details from yourself. Number 2. Double-check your units and terminology. Seriously, do not confuse rate with time. And number 3, this is the absolute biggest killer. Answers are not specific to the context given. You really need to scan your own answers for these exact errors before you even think about moving on to the next question.
When you put all this together, you get what I like to call the winning formula. First, state the biological concept. Next, back it up with specific evidence or data from the figure. Then, apply your scientific reasoning to explain exactly why the data shows what it shows. Finally, package the whole thing up in precise examiner wording. When you combine those 4 elements, you make your final answer completely bulletproof.
But here's a pretty terrifying reality check. What if you have this winning formula down perfectly? You understand the complex biology of enzymes inside and out, yet somehow you misinterpret the very first word of the question prompt. This brings us to a massive hidden issue that will completely destroy even the absolute best revision efforts.
Because honestly, your flawless enzyme knowledge is not going to save you if you decide to describe a graph when the examiner specifically told you to evaluate the data. These command words completely dictate exactly what the mark scheme looks like. If you get that command word wrong, you are literally playing the wrong game entirely, and that is exactly what we are going to solve in our next explainer.
Leaving your mark band to chance just because you misunderstood a command word is a risk you simply cannot afford to take. So hit subscribe on our YouTube channel, Ace the Exams, at acetheexams_IGCSE to absolutely excel in your Cambridge exams. Hit that button right now and jump straight into our Command Words Masterclass Explainer. I'll leave you with this. When you're sitting in that exam hall, are you truly answering the question they asked or just the one you wish they had asked? Think about it. See you in the next one.